everyone. Welcome to the first HaskellerZ meetup in 2020. I'm happy that today we're starting with Marion and Alexis from Azura. Before we go there, as always, we're always looking for talks, so if you have anything you would like to talk about, please let us know. Reach out to us on the meetup platform. We still have lots of open slots this year. And also look up the Zurich Friends of Haskell Association if you want to support the Haskell community in Zurich. We'll soon also have upcoming General Assembly and a new election of the board. And with that, without further ado, let's get started with the talk.
Okay. So first of all, thank you for having me here at Haskell Meetup. It's my first ever Haskell Meetup, so it will be cool. So, as Andres already said, I'm here from Azura, and I want to talk to you about how you can contribute to an open source project with Haskell, just like one example. So first of all, I want to introduce myself quickly. So my job, I'm a developer experience engineer at Azura, which means I'm responsible for documentation, GitHub issues, and in general, the developer experience. So if you look at it and you have any feedback, like for example, you don't find something in a documentation, I'm to blame, so you have to come to me. Then, in my free time, I'm also a community organizer in Zurich, so I'm running a few meetups, the Women Tech Makers meetup, the GraphQL meetup. So, and everybody's welcome also in the Women Tech Makers meetup, so feel free to sign up. And on the weekends, I started riding dirt bikes, so this is now my free time occupation. It's like my backup career in case something goes wrong with programming. So, yes. And we've already seen her before. I want to introduce our remote speaker, which is Alexis King. I think everybody knows her from Twitter. She's the tech lead for Haskell at Azura, and she knows the most about the whole server architecture, which is why she will do the presentation on the Azura GraphQL server. First, the agenda of today. So first, I will introduce GraphQL. Who already knows GraphQL? Almost everybody. Then I want to do a quick demo on how you can build an API with Azura. Then Alexis will talk about the server architecture, and you can ask her all the questions you want. And finally, I want to tell you how you can contribute to Azura. Now let's first talk about GraphQL. So GraphQL is a typed query language. Typed here is very important because this is different compared to other query languages. So everything is typed, and this reduces the chance for mistakes if, for example, you cannot make an object that has the wrong types. Then compared to other for example, REST APIs, you only have one endpoint. I will show this later in an example. You can have nested resources. So for example, if you have a user and the user has a profile, you can get both information from both tables in one query. You don't have to make one request to the API, get the user ID, and then make another request to get the user's profile. The developer workflow, especially in bigger teams where you have front-end and back-end teams, is a lot easier if you only have one endpoint, because otherwise, if you have to provide new endpoints for all the resources, the front-end engineers always have to wait for new endpoints from the back-end engineers, and the lifecycle can get very slow. And you only get the exact results. So for example, if you only need the email and the name from a user, but not everything else that comes with the user, you only get these two fields. Now let's look at an example. This is from the official GraphQL website. So this is how you would define a type in GraphQL. You say project, and then as you can see here, the types for all the fields, name, tagline, and contributors, we define the types. Then we make a query, we ask what we want. So we say from the project, from the projects, we only want the project with the name in GraphQL, and we only want the tagline and not all the other fields that we store in the table. And this is then the result that we get. Exactly what we asked for, not more and not less. Now, as in a lot of companies, also big companies like Facebook and Twitter and a lot of other big companies, GraphQL is starting to replace REST. And I just want to make a quick comparison. So some of the things I already said. So for REST APIs, you have an endpoint for every resource, and there is chaining. For example, if you need the user's profile, you have to have the user, the ID, and then the profile. So if there are a lot of nested resources, this can get very messy, and then if you change the relationships, you have to rebuild your whole architecture, which is a lot of work. Then with REST, you use all the different HTTP methods like get, post, update, and delete, and the potential for overfetching or underfetching is pretty big. So sometimes you get too much information, but you only need 2 things, or you don't have enough and have to make another API call. On the other hand, for GraphQL, you have one endpoint. We've already said that, and it's always a post request. There is possibility for get, but with Hasura, it's always post and always one endpoint. So for the front-end developers, in the config file, instead of having like 20 or 200 endpoints, it's the one, and you can access all the resources from this one endpoint. And you only get the data that you need. Now, let's look at an example. So I learned GraphQL with a thing called Star Wars API, but I don't like Star Wars, so as soon as I knew how to do it, I built my own Harry Potter API. So this was the REST example. So let's say we want to have a list of movies. So this will be /movies. Then we want to have the list of the characters of one movie, which is /movies/movie ID /characters. And now we want the actors of the characters of a movie, and you see where this is going. So this can get very complicated. Now, let's say you want to try GraphQL. You can build your own GraphQL server, not a big deal. But you don't have to. You can use like GraphQL server that already provides you with ready API to build. Let's introduce quickly Hasura. So Hasura is a real-time GraphQL API. Real-time means that, for example, if there are updates on the API, you can get these updated in real time on your front end. You don't need to reload, you get instant updates. Then it's open source. If you need to know how it works, you can go look in the source code. Underneath, there's Postgres running. So this is probably the most interesting thing. So what happens is a query comes in GraphQL, then it gets translated to SQL, run against the Postgres database, and then sent back directly to the client as a JSON. And Hasura is currently the fastest GraphQL engine on the internet, and the reason for this is because it's built with Haskell. So we have 3 like physical components of the GraphQL engine, which is the server, is built in Haskell. Then we have a CLI, which is in Go, and a console that we will see later, which is in React. So yes, what we want to have low latency. So when we make a query, we don't want to wait for the results to come back, we want them immediately. We need high throughput because, as we've seen before, we can have nested resources, and this nesting can be like unlimited, so you can have a lot of nesting. So it needs to be fast to get all these resources. And it should be light on resources, it should not use a lot of CPU and memory. Now, let's look quickly at what Hasura can do. So it's easy to use authentication with Hasura, although authentication is not built in with Hasura. You need either your own authentication webhook, or you do it with JWT, or you integrate it with Firebase authentication or any kind of authentication service. Then authorization is one of the biggest features that Hasura comes with. So there's row-based and column-based access control. I will show this later in the demo. Then a lot of people ask about data security because Hasura runs in a Docker container, and you can deploy it to any kind of cloud provider that is running Docker, which is every cloud provider like Google Cloud or AWS or anything, but you can also run it locally in a Docker container. So we have some larger customers like Philips Health that run with patients' data in the hospital, so they cannot have this information in the cloud, so they just run it locally on Docker. And for business logic, because sometimes just database interactions are not enough, then we have you can have event triggers on the API that trigger serverless functions. For example, if you subscribe to something, you can have an email service that gets triggered based on a certain database event.
Are these functions triggered externally to the server process, or they're part of you compile them into the server process?
They're external.
Okay.
So you, for example, have a function on AWS, an AWS Lambda, for example, and then this gets triggered, and you just provide the URL of this event trigger, and then this gets triggered if something specific happens. So, enough talk, let's do a demo. So, the easiest is to do the Heroku quick start. So we can just go here. I hope my hotspot is fast enough. Okay, so let's say the name has to be unique. So it's green, which is fine, so we can deploy the app. And this takes like 10 seconds, so in the meantime, we look at the template that gets deployed, which is this one. And in the app.json, we can see here the configuration. So you can see here that automatically Postgres add-on gets deployed when we do the quick deploy. And if you don't specify anything else, it's with the HobbyDev, which is the free tier of Heroku. So also Hasura is completely free to use. If you at some point deploy to Google Cloud and you have 1 million users, then you pay to Google Cloud for the traffic, but you don't pay anything to Hasura. So let's see if this worked. Yes. So we can view the app, and then the first thing you will see is the Hasura console, which looks like this. This is GraphQL, which comes from Facebook, so this is not Hasura specific, we just use it. You can also use this for any kind of other GraphQL server. So let's add some tables. First of all, let's have a quick overview. So this is the endpoint that we access. Maybe later from front end, we just configure this one, and as we can see here, it's a post. Here we can define request headers. For example, later we might have authentication, so we might send here an auth token in the header. Then this is the place where you can try out queries and mutations, and this is where you get the results. So let's create a table called movies. It's a UUID. I think everybody's familiar with basic database stuff like UUID and primary key and stuff. Oh. So we generate this randomly. Then movie has a title, which is text, and a release date. Primary key is ID, and we add table. I have to say, all that I'm doing here in the console can also be done over the CLI with the API. You don't need to, if you like more in the code than UI, that's not a problem. So because this was so nice, we want to do it again. So we add a table called scenes. Same here. And scenes has a name and takes how many times we need to fill the scenes up before it works. So we add a table. Now we add some data. Later, obviously, we will not add data here over the UI, but over any kind of front end. Let's just keep this simple. Two movies. Now what we can do is we can make a simple GraphQL query. Query movies, and from the movies we would just ID and title. And then this is what we can. Very quickly I can create a relationship as well. So in the scenes table we add a movie ID. And then we have, yes, it's added. Then we have a foreign key. We are in the scenes table, so we have to reference the movies table. And we say the movie ID in scenes should equal the ID in the movies table. And we save. Now, on the movies table, because this is an array relationship, one movie has many scenes, we go to relationships, and then you can see here it's suggested that we can add this array relationships from movies to scenes, and we just add this. Now, when we go to scenes, we can see here that we have an additional movie ID that is null because we have already two movies that don't have a movie ID, so let's add this quickly. Both scenes are in the same movie, so this here and the same here. Okay, now we can update our query, and we can add scenes as well, and we just define what we want from scenes, and we want just a name. And so like this you can have these nested resources that I was talking about. Then now we've seen how we can make queries to the database, but later you will also use mutations to insert or to update something from database, but I think this is out of the scope of this talk. But just that you've seen how this API looks like. Maybe something that is interesting. Yes,
Right.
sure.
Is it okay to ask a few questions?
Sure.
I mean, we have enough time, like
Yeah.
1.5 hours reserved, because what I see to the left looks really interesting.
To the left.
Yeah, like if I look at movies, then it seems like it has an order by, the where. To me,
Yes.
it looks like you have your own database definition language, and from these table schemas, you automatically generate the corresponding GraphQL schema,
Yes.
which has some special properties,
Yes.
because usually you wouldn't put that. Can you give us just sort of an overview of what are the things you have there, or will that come later in the talk anyways?
You mean what you can do with the queries and stuff like that?
Yeah, like what is the order by, what is the where,
Okay, sure.
movies aggregate, and so on.
Yes, so this all gets generated automatically when you create a table. First of all, you can't see this here, but in the mutations, the insert function and all of this gets created automatically. And here you can, for example, let's say we want to have a limit on the movies, and we just have 2, so we say 1. And then you only get the 1 movie. So there's basically all the database operations that you're used to, like making limits or order by, for example, we can order by date, something like this. And then ascending and descending, so you can choose all of these things. And this GraphQL Explorer is not new, but we've had it for a few months. So if you don't know, for example, if you're new to GraphQL and you don't know how to type this out of your head, you can just click your query together from the beginning. Or also mutations. So it's very easy to use. And this this graphical we usually just use to test queries. Then when it works, we copy it to the front end. If, for example, I have a Vue.js front end, just copy it, and then it also works from there. So this is like a playground. Yeah.
Reminds me a lot of Access, Microsoft Access.
Ah, okay.
You build your just graphical front end, you build a database, and have some simple query language.
Yeah.
I mean, it's like it's an evolution of it.
Yeah.
But yeah, I mean, I wonder, like, if you compare the features, like what would you miss from Microsoft Access if you look at using it in that way? What would you miss from actually using PostgreSQL directly? Because it seems like you do constrain what kind of databases are behind.
I don't know Microsoft Access, but maybe Alexis knows. Alexis?
I also am not particularly familiar with it.
Okay.
Yeah, that's a generational
so
difference.
What you have to what you have to do is just try it and let us know, and then we can.
It looks super cool. This is very nice.
Yeah, and then I wanted to talk about permissions because this is. So we have role-based permission system. So behind the scenes, if I add a new role, a separate schema gets generated for each role. So for example, if I restrict permissions for a certain role, it will not even show up in the graphical explorer. So I don't even see, for example, if I say the role user should not see the title of the movie, it will not even be selectable on the explorer. So let's see an example. So for example, I actually built the Harry Potter API, and I don't want people to delete my movies. So I just want to be able for them to select it. So I just say user, and insert, update, and delete. I leave so that people cannot change anything. But for select, I say with custom check. And the thing that happens the most often is that you have a user that is logged in, and then you need to compare the ID that the user sends with the ID that is in the database. So I can say ID equals access or user ID, and access or user ID is something that you will send with the request headers. And then I can also say, for example, they should not be able to see the ID, but just the title. And then I can save these permissions. So this is how you can, because you have you restrict the access to the database over permissions, etc. This is something we looked at relationships. Remote schemas, this is something interesting. So if I have another GraphQL service, I can stitch it together with my current GraphQL service and then use them like from one single point. So if I add another GraphQL server here, then I can make queries to both of them and I won't even know from where it's coming. So this allows companies or projects to have microservices, different teams working on their own microservice, but then in the end, people being able to use the data from one specific point and not having to access several APIs. What we're introducing at the moment, and it's already in preview, remote joins, which will allow you to even have in one query results from tables in your current API and from the other API. So this is something that will come very soon. And events, this is what I was talking about before. When you have an email service, or maybe you have a payment service, then you can create an event trigger, and maybe I have my email service on AWS, and I say email service, and add here the URL where I write this on a serverless function, or use any other service that I can add here. Then I define, for example, or let's say, yes, email service, and I say when a new movie gets inserted, I want the people who subscribe to this to get an email. So this is how I can add an event trigger like this. So this is all very quick, but there are a lot of tutorials that show how to do this. And what I wanted to show, because maybe this is interesting as well, so you don't need to create your tables or add your triggers with the UI and clicking these things together. You can also just write your raw SQL, and this allows you to write also SQL functions or create views that then you can access over the console as well. So it's just everything that works with SQL will work here as well. Yes,
May I challenge that? Like, what about custom data types? Let's say geoinformation system data types. Would they be supported, or I guess you have a limit there?
You mean PostGIS?
Yes.
Yes, we have it supported.
Okay, so somewhere there's a list of what do you support of this, but in principle you take
yes,
the Postgres database schema and on top of that you compute.
Yes.
Wow, cool.
Alexis, did I forget something important?
No, that's
Okay.
all seems good to me.
Okay, good. Then what's next? Yes, Alexis, you're next. I will stop sharing my screen, and then you can present.
All right, let me share my screen. Oops, it's not the thing. All right, can people see
Yes.
one slide? All right, great.
Marion, can you go full screen? Probably on view.
Wait a minute, Alexis.
Right, it's there to the very left of Zoom, very right of Zoom. The 5 down, 2 down. Yeah, it's Zoom to the right. Is this YouTube
this
full screen symbol?
Yes, perfect. Okay, Alexis, you can go.
All right. So let's see. I guess I should briefly introduce myself. My name is Alexis King. I've been working at HaskellerZ for about 6 months, and I think for the most part, for this portion of the presentation, feel free to just ask questions and interrupt me. Obviously, it's hard to know if somebody has a question since I can't see you, but feel free to
I will
just
let you know.
ask me. All right, great. So Marion kind of talked a little bit about sort of what the GraphQL engine does, but I sort of want to talk about a little bit, just from a high level, both how it works and some of the details about how we've gone about building it and some of the tools that we've used. So there's sort of a running joke that everybody who's into programming languages thinks that every application is a compiler. And maybe that's sort of true, but in this particular case, I think GraphQL engine actually, it is, in a very real sense, it's a compiler. So the idea is pretty simple, I think, to understand. We have GraphQL queries, people send them to us, and we need to type check those queries and then compile them to SQL. And interestingly, though, we also sort of have a compilation going in both directions, because we also have to generate the GraphQL schema from the Postgres schema. So in that sense, we basically have to do a lot of the same things that you would see in any other programming language compiler, although it's a little bit different given that we're generating SQL, but it's a just-in-time compiler. So because of the fact that we don't know what the shape of these queries are going to be, we have to do this compilation in real time, which means that there's a very strict time constraint. Every millisecond does end up counting. And the schema generation, though, it doesn't need to be as fast because that we sort of load the schema when we start the application, and we store that in an in-memory cache. So mostly you're going to focus on the first part of these two things. So if you kind of look a little bit closer at the compilation pipeline, the idea is where it comes in. And there's a few different phases that it goes through to actually get to SQL. So the first part is that we type check it. So type checking and then actually sort of constructing the SQL, or the internal AST that we use to represent the queries. That's sort of interleaved. And we do kind of the validation checks. And as sort of a byproduct of validating it, we construct an internal AST. Then once we've done that, we sort of integrate additional filters and things like that for the permissions, because some of the permissions rules are caught by the type checking process, because if you're not allowed to query a table, then it's just not in the schema. But it might be that, like, okay, maybe you're only allowed to look at particular rows in the table, and so in that case, we have to sort of augment the AST, the query AST, with a filter based on those permissions. And then we actually do the process of converting that internal AST into a SQL AST, and then eventually we spit that out to Postgres. And there's not really an optimization passing here, which is mostly because of the fact that we can actually just sort of rely on the Postgres query planner to do the optimization, which is really great. So for the most part, we just have to focus on generating SQL queries that Postgres query planner likes, but that's actually not too hard. So for the most part, we get a lot of this performance for free just because of the fact that we're treating this, we're just generating SQL queries that correspond directly to the GraphQL queries. We're not sort of, so actually, I'm going to give just a very small demonstration of that. So if you click this Analyze button in the GraphQL console, it'll actually show you the SQL that's generated in the Postgres query plan. And so you can see that the SQL that's generated, this is a very simple query. we're just generating, we're just querying this record and then something that's joined to it. And the query, if you look at it, it looks really big and complicated, but I mean, a lot of this is just because of the fact that it's just kind of an artifact of the fact that it's machine generated. But we don't really worry about generating a super nice, pretty looking query, because if you look at the query plan, this is a really good query plan, and this is basically exactly what you would get. It's the same query plan you would get if you wrote the same query by hand. And so Postgres does a lot of that for us, which is very nice. So that's sort of the high-level idea, and it turns out that this is actually kind of most of the application. And one of the really nice things about it is that a lot of this stuff is really pure. So in a lot of web applications, it's kind of challenging to find large chunks of actual business logic that are truly pure, but in this case, that is actually true. So this is sort of two functions for sort of resolving selects. And I'm not going to go into the details about what every single one of these types happens to be, but even though this is sort of monadic, it's mostly just operating in sort of pure error monad, read monad, but there's not actually any I/O in here, so that's really nice. And then the process of going from that sort of internal AST into SQL is just a simple pure function. And so that's really convenient, and it lets us take advantage of a lot of the nice aspects of Haskell as a programming language. So that's great. So there's a few other odds and ends that I want to, excuse me, that I do want to touch upon very briefly, just to kind of mention them. So one of the other things that we do internally is when GraphQL engine can respond to schema changes from the console without having to restart the whole instance. So if you horizontally scale your instances, we use Postgres listen notify to synchronize sort of reloads across those instances. We also use that to handle event triggers. So we have a feature that we can sort of hit a REST endpoint, hit a webhook after when we insert something into a table, and we use listen notify for that as well. And then we also have a small bit of logic for handling if you sort of have remote GraphQL servers and you want to incorporate them. Marion mentioned that a little bit. We have some logic in there for stitching things together, but for the most part, that's the whole application. And it's actually not, it's not architecturally very complicated. It turns out that there's a lot of subtleties to doing it in practice, but it's nice how simple it is from a high level point of view. So, given that, I now kind of want to talk a little bit about sort of the Haskell specific tools and libraries that we've been using here, just because presumably people are familiar with some of those things. So we did recently actually switch from Stack to Untitled as a build tool. So that's been nice. It's just a minor thing. If people are interested in why, I can talk about it. Excuse me. But actually from the perspective of the application, a lot of the libraries we use are pretty simple. So we just use awk for HTTP, which is a really simple, if you're familiar with like Ruby, it's like Sinatra, or sort of just kind of the simplest kind of HTTP server you can have, because it turns out a lot of our logic is not really at the HTTP layer, so using something fancier than that isn't particularly important. We don't use an effect system or anything like that. I would actually like to change this, and I'll touch upon this a little bit later, but we've just been using MTL and Mono transforms. This is kind of a weird quirk. This long predates me, but we have sort of our own wrapper around libpq, and the main reason I think we have that is because a lot of the other Postgres libraries in the Haskell ecosystem don't support listen notify, which we use for the asynchronous eventing. But to be honest, I don't think we really need to have this, but it's fine, it doesn't really matter. It mostly just works the same way that other libraries do. And we also have our own hand-rolled GraphQL parser package, which just actually, as the name implies, parses GraphQL queries. And that is all of this code, all of the stuff that I've talked about is totally open source. GraphQL parser is not on package or anything like that. I think probably because we just haven't put enough effort into it to get it to a point where we feel like it would probably be useful for other people, but if other people are interested in doing GraphQL related things in Haskell, it's available, and it works reasonably well enough for us. So if any of you have read my blog, you'll know that I'm an advocate of using lots of Haskell language extensions, and that's certainly true for us. We currently have 34 language extensions that are enabled by default. The truth of the matter is most of these are pretty minor changes, and things that people wouldn't really worry about. But we've taken a pretty free approach to adding these. I don't think anybody really, there's not like a large discussion when somebody says, oh, I want to add this new thing to the list. We mostly have this is just like the set of the set of extensions that we found useful. And it does continue to accumulate and grow over time. So some of the things that are really nice for this particular application, from our point of view, for being able to use Haskell, is because this is one of the reasons that people talk about Haskell as being a good language for building compilers, is the fact that having algebraic data types is wonderful for modeling ASTs. And so we have lots and lots of different kind of internal representations of various things, and having access to algebraic data types makes that really easy. I recently wrote a blog post about kind of some of the philosophy that I've been trying to push us towards in terms of how to model things using the type system, take advantage of the type system. It was reasonably popular a couple months ago, so it will be something to read. So another thing is, for the most part, we haven't taken advantage of anything that's super fancy. We don't use like the singletons library. We don't do a whole lot of dependently typed triggering in Haskell, but we do take advantage of a lot of the sort of abstractions that Haskell as a language provides. So very recently, I was working on something that started incorporating arrows, which are sort of a lesser known, less loved aspect of the Haskell ecosystem. But I think that's one of the really nice things about working with Haskell, is that even though this is kind of a complicated domain, like some of these algebraic data types that we're dealing with are very, very large, and some of the behavior is very complicated, there's always sort of just an abstraction that exists somewhere, if you look for it, that makes a lot of these things much simpler than it would be. And so we use a little bit of lens, a little bit of generic programming to help dealing with these giant data structures. So a few just like random pieces of information about my experience working on this code base with Haskell over the past 6 months. So the first thing is, everybody talks about this is not new. I'm not the first person to say this, but refactoring Haskell code really is wonderfully simple. And I think that it's been really important for us, because even though we haven't been a startup for a while, it wasn't that long ago that we were a startup, and a lot of the code is definitely startup code. So with everything that entails, so there's a lot of parts of the code that just don't make a ton of sense, or that we wouldn't, like from information that we've learned since then, we certainly wouldn't do it that way today. But it's been very, maybe very easy is too strong, but it's been very possible to completely rip out sections of the code and completely restructure for logic without actually being too worried about breaking things. So that's been really wonderful. Some of the less pleasant things, Haskell, unlike some more modern typed functional languages, doesn't have any support for structurally typed records. So if you're familiar with like PureScript or even OCaml has sort of a different approach to this, but you can sort of have anonymous record types. And that turns out to be really useful, because you can have record types sort of grow and shrink over time. Haskell doesn't have anything like that. And this, from my point of view, is one of the biggest pain points of working in Haskell at the moment, especially in a domain like this where we have all these complicated different data representations. We end up with like situations where you have 3 different data types and they're almost the same, but they're very slightly different in minor ways. And that's unfortunate. Another thing is that dealing with minor transformer stacks can be a real problem. I think with a lot of sort of more traditional product applications, people just kind of build one transformer stack and they run their whole application end. But that's definitely not the approach that we've taken, because we have these sort of different phases of the application, and it's very useful to be able to sort of add and remove effects. And so dealing with motor transformers has been a bit of a pain. So I actually sort of recently started looking into this, and this is something I can't really claim that I've been doing this on the clock. A lot of this I've been doing in my free time, but I've started working on sort of yet another effect library. And if people are interested in that, I can talk about it. But I'm hopeful that this will be something that we'll be able to use relatively shortly. I'm still looking at the details of that, but initial results are promising. So we can do that soon enough. And this is also open source. So a few other random odds and ends. So I do think that using the type system has been very helpful. We also have a very extensive end-to-end test suite, and it is impossible to overestimate or oversell how important that's been for us, especially because we have this really complicated integration with Postgres, where sometimes we generate some sort of strange queries, and being able to actually execute tests against Postgres is really important, and that's sort of something that's difficult to just guarantee with the type system. So that's been really helpful as well. This is something that people, like everybody kind of agrees that Haskell's really good at this, but people don't talk about it very much. I think just because it works so well that nobody really thinks about it all that much, which is the concurrency parallelism feature. So we use this a lot, not just in the sense of sort of the usual HTTP server way, we spawn a thread for each request, but we also have event triggers. We're currently adding a feature, sort of something that's kind of cron-like. We have this, we built this for, we have an efficient implementation of live queries, where you can sort of subscribe to a query, or send results as that query changes. We use this to deal with synchronization and a lot of those things. And it all just works pretty much the way that you would want to, not a lot of effort. So that's really wonderful. Another thing that we found is a lot of, like, our performance is mostly, we haven't spent a ton of time actively trying to make our performance great. And it really, yeah.
There is one question.
Hey, Alexis, can you hear me from this distance?
Yes, I can.
Awesome. On concurrency, way back when, I was also working on a web backend in Haskell for a startup. And concurrency was working really great, but monitoring actually what was going on at runtime was really difficult. Like, you don't get by default sort of a good overview, okay, what threads are running, what are they doing, where are they blocked? Do you have that experience as well, or is this something that is fixed now, or you fixed it using your own homegrown fork that monitors the threads a bit better?
That's a good question. So I haven't personally spent a ton of time like looking into that. I think you'll sort of, give me a second to think about this. I haven't spent personally a ton of time working on that, like looking into those kinds of issues. So for the most part, it mostly just worked from my perspective. I don't think we've had a ton of issues trying to understand that, because a lot of our parallelism is pretty coarse-grained, which means it's not too difficult to sort of just kind of fork off a thread, and it's going to run for a while, and so we're not too worried about that. I will say though, like, the tools that I have used, have looked at this, is the GHC event log is super useful. There's a wonderful tool called GHC event log analyze that sort of, it's a little bit like, there's thread scope, which you might be familiar with. I don't know, you might be familiar with these things. But thread scope is sort of the usual tool that people use or point people to analyze threading performance. And that's useful, but I think that it's kind of, sometimes the information it tells you is hard to read. But the event log, GHC event log analyze, lets you sort of insert a little bit of instrumentation in your program, and it shows you the cost breakdown on different threads and when threads start and finish, and how much time is spent in thread scheduling and that sort of stuff. And that's been really helpful for the few times that I have looked at that.
Yeah, that's cool. Actually, now remember that these tools, they have been built actually after the time I was referring to. One thing that I recognize though is that for a long time there seemed to be a bias in the Haskell community towards sort of one-shot programming. Like you run a program and then you analyze what it's done, whereas actually for server development, you want to understand when the server is running it, okay, where is it stuck, what's going on?
Sure.
Are these tools you're referring to as you've used them, can you attach them to a running Haskell server, or is it something that you sort of have to set up specially and you even have to shut down the process to get the results?
Yeah, that's a good question. So I agree with you that I think Haskell has relatively little support for being able to just sort of like attach. You can't just like attach a debugger or something like that to a running process without sort of starting it with debugging enabled or something along those lines. I think that in our particular case, that hasn't been too much of a problem. And I think that even like, because of the fact that most of the people that are running our server are not us, right? They're our users, which makes it hard to analyze those things directly. So for the most part, when people have a performance problem, we've figured out how to reproduce it locally. And so it hasn't been as big an issue, but definitely it would be nice to have something that was I don't know, just a little bit easier in that regard. The event log does allow you to sort of turn on subscribing to the event log, and so you could build something like that would be, you haven't done anything.
Thanks a lot. It's very helpful.
One more question. Can you tell say a bit more about the end-to-end testing and exactly what kind of techniques are you using?
Sure. So it's really it's not particularly complicated or particularly sophisticated. I think that so currently our end-to-end test suite is written in Python, which I've been kind of perplexed by. Nobody Marion mentioned that we have a few different teams writing a few different languages. None of those teams are writing Python, so I don't really understand how the Python came about. We've actually been trying to migrate that to Haskell, but in any case, it's basically just we have a bunch of different tests that say, set up the database this way, make these queries, expect these results, and we just run them. We run them in CI. They take quite a while, but we have a lot of parallelism, so that helps it out. It's not anything that's particularly clever. We have a little bit of smarts in there to sort of say, like, well, okay, we want to run the same set of queries in a few different ways with a few different configuration options. We run them like over HTTP and over WebSockets, and then sometimes also reuse the same queries to exercise the live query machinery. But it's mostly just a bunch of expectations that we get them when we add features or when people file bug reports.
Okay, thanks.
I have a question. Can you parse the SQL that's generated and bring it back into your original form? Well, not, or at least into the same framework, and then test that you actually the same structures?
So we do not currently have a SQL. We have not written a SQL parser. We don't ever do any parsing of SQL. We could. It would be maybe potentially. I'm not entirely sure what we would do with it, but I'm sure that there's we've started to explore a little bit of property-based testing, but it's a little bit challenging to do property-based testing because of the fact that it's difficult to excuse me. It's difficult to generate well-formed queries that are both valid queries but also exercise interesting things, if that makes sense. There's a lot of subtleties in figuring out how to do that, even though GraphQL is typed. So maybe I'm sure there's more that we could do there, but it hasn't been something that we've explored too much so far.
Actually, as we're talking random nodes, it's a different question, but I was just wondering, like, JSON data types in the SQL tables, how are they supported? Can you dive deeper into the JSON data type if you give an extra schema?
Into the JSON data types? We currently, I don't believe I'm pretty sure that we don't currently support any of the operators for drilling down into JSON data types. I think that's actually probably just like it hasn't been implemented. I think it would probably be very easy to add that, but I don't think we currently support it.
Thanks.
One of the, just kind of an aside, I think one of the things that I found from working on this is that GraphQL, it's a very simple language in the sense that it's very limiting in a lot of ways. I think that, even though I had done a little time with GraphQL before working here, I hadn't really understood the limits of it. And I think that there's a lot of things that it should be really easy to write to encode into GraphQL, but aren't. And that's been both sort of a blessing and a curse. It's a blessing in that it really keeps us honest and we can't sort of go off and try to invent some really complicated query language. But it does sometimes make it difficult to encode Postgres features into the GraphQL schema in a way that makes sense. So that continues to be a challenge and will continue to be a challenge. But I think the balance that we struck is good so far. So let's see. Going back to this, yeah. So Haskell is a lazy programming language. People often talk about performance issues related to laziness. We haven't really found that to be too much of a problem. We do use strict data pretty much everywhere as the default. We don't actually use the strict data language extension. We probably should, mostly just because I think the code base predates it. And we never went in and tried to change all the data types to be strict data instead. But in any case, it's definitely been very helpful to control the amount of laziness, especially because if we have sort of data that's sitting around in memory for a while, like these various caches, we have a planned cache, a query plan cache, and the schema cache. Both of those things have a lot of data that's sometimes infrequently used, and so making sure that all those data types are strict avoids leaking memory due to laziness. And so we haven't had to spend too much time doing performance profiling, memory profiling, so that's been nice. And we've also definitely recently been trying to figure out how to even though it's open source, we don't get a whole lot of open source contributors. Marion will talk a little bit about the contributing after I'm done talking here, but I think some of that is just that, some of it's that there aren't that many Haskell programmers, but also I think some of the code is kind of difficult to understand. So we've been definitely trying to improve documentation, internal documentation. We've I don't know if people are familiar with GHD's notes system, but they basically just have, they write comments in the code in places with sort of labels on them, and then in other places in the code, they just have like references and comments to say, look at this note, and that works really well. And so we've been kind of experimenting with doing something similar, which is helpful because some of the subtle details about generating things in such a way that Postgres is happy can be very complicated to keep it all in your head, and so that's been useful to disentangle the invariants for some of these things. And that's really all I have to say. So if people have other questions, feel free to ask.
More questions?
Sorry?
Yeah, I have a question. So the obvious choice initially, I mean, it was before you started the company, but would have been to extend Postgres with a T. I think there were some efforts to add GraphQL to that. Do you know a little bit what the choices were to kind of do a rewrite instead? Postgres is a bit of a hack, right? Because it encodes the queries in the URL itself.
Mm-hmm. So this decision certainly predates me. The history of GraphQL engine is a little bit, like it didn't originally actually start as even kind of the thing it is today. Originally it was sort of a broader in scope thing that didn't use GraphQL. So there was kind of our own query language, and it did things in addition to just being sort of, you put a thing in front of a database. It was kind of designed to be more of a more general service, and then kind of evolved into this. So my guess is that it's probably just kind of a historical accident. I don't know how difficult, I don't know enough about, like I've toyed with Postgres, but I don't know enough about how it works internally to know how difficult it would be to add GraphQL to it. So it's not a very satisfying answer, but that's all I know really.
That's a good segue to my question. I'd like to learn a bit more about the company itself behind Hasura, how the teams are structured, and you're saying it's open source, but I mean, you also need to at least pay your salaries and probably also make the equity worth something. If you could share a bit more about this context, that would be interesting. Perhaps there's a different place in the talk anyways, it's just
No.
I can say what I know, and Marion can probably add something soon as well. Definitely, obviously, we have to keep the lights on. So a lot of the money that we are actually profitable, I should say. We're not reliant on VC money, so that's nice. And a lot of the money comes at the moment from, we still support contracts, which is the way that a lot of companies that do similar things, so we do make their money. We are also in the process of developing a sort of hosted version of our service that will, that you can pay money to us for, and we'll give you both that and also a few kind of additional things that we can do because of the fact that we control the environments and we're hosting it. But that's currently not, we have a few people that are sort of testing that, but it's not publicly available at the moment because it's still kind of in early stages of getting all that set up. But that's better.
And the third thing is that we have launched a pro version, which is for teams in production. It doesn't necessarily introduce new features, but just makes them easier to use for big teams. And this is also what larger corporations will pay for.
So that's the pro version of essentially the front end, mostly?
No, it's more like, for example, that you get statistics of your queries without you having to analyze the logs and stuff like this.
I see. So yeah. A dashboard as a Docker container.
Yeah, exactly. So it's for bigger teams that need these kind of statistics, but if you're a small team or a single developer who just needs an API, then it will be, and it will also, what's open source now will stay open source forever.
Very good. How many people are you guys? How many people are you?
By now, I think it's like 35 or almost, I think by the end of the next month it will be 40.
Wow. How many engineers?
30, I guess.
Let me see. So, I'm mostly familiar with obviously the server team since that's the people I interact with on a regular basis. I'll just try and do a count in my head. I think, the server team is like 10 people.
Yeah.
It's
10 Haskell.
Yeah. And then people working on other things, I think are a little bit smaller. But.
And how do you expect, I mean, how does your product compare to the other options for developer to either have the GraphQL API or actually have another API which is really easy to set up? I'm not an expert on that, but I just wonder sort of what's the market share right now and how you expect it to develop. Are you the leader in your category, or?
I don't think we have like this most direct competition where there's another product that is doing exactly the same. Right, Alexis? So I don't know of anyone, but a lot of people ask me, for example, what is the difference, like why would you use Azure and not Firebase, for example, and there the answer is clear, it's open source, the data is yours, and yeah. So these are the kind of other options that you have. Alexis, do you know of something else that could be like more similar?
Yeah, I mean, so for a while, I think our closest competitor was Prisma, which is, they were doing something that was quite similar, which was that, I mean, wasn't exactly the same. I've always felt like their angle was kind of strange, which is that their angle was kind of, you can run, like, we'll help you run a GraphQL, we'll help you generate a GraphQL API from your database, but not really in a way that's suited for external consumption, but more for like internal consumption if you have a microservices architecture, which I never found particularly compelling personally. But so like they didn't have a lot of features around dealing with like permissions and things like that to make sure that people just can't look at your whole database. Now they have sort of a more sophisticated thing, but they've also recently, as of just like the past, some point in the past 6 months, they've abandoned GraphQL. So now they have their own query language. And so it's, I don't know that much about what that query language is like or what it does and does not do, but it's definitely, it's less of a direct competitor than it used to be. There's also GraphQL, which is sort of similar, but also doesn't support a lot of the permission key type things that we do. So there's people that are similar, but nothing that's exactly the same. Oh.
Thanks a lot.
I have one more question. How hard would it be to add another database to it that speaks Postgres, like Cockroach, or I think Hugo is another one?
How hard would it be to add? So we currently do, I know that we have users that are using timescale DB, which is sort of, I mean, it is Postgres, but sort of an extension to Postgres. I know it's a little bit different in some ways, but it shares a lot of the same logic under the hood. I think that I haven't tried using it directly on top of something like Aurora or Coverage DB. I think that there's some, like we definitely do certain things that are not supported by all of the, so one of the big issues is that we spend a lot of the way that we do the query generation, the schema generation, is by reading Postgres catalog tables and things like that, which are not the same across sort of people that sort of speak the same general API. We are kind of, so one, we're definitely trying to figure out how to support multiple backends sort of in a more general way, where we could support MySQL or something like that, or even something that's not even SQL. And obviously this would be related to that, and that would be even easier. And then we're also trying to figure out how to, basically, because currently we store sort of the information about your schema and things like that. We store that in the database as well, and we're trying to figure out, make it possible that you can have sort of a configuration file. And that would probably make it easier to support those kinds of other databases that are not quite Postgres. So I think there's currently some obstacles, but they're certainly not enormous obstacles.
And one last question, if I may. So I think one of you earlier mentioned horizontal scaling. Is it possible to add a couple of instances and have the server sort of load balance between them, or something in that direction?
Sorry, is it possible to have more?
Yeah, could you have multiple Postgres instances, but just one server? Or,
So yes, but not like, it's not built into, you can use something like the existing support for Postgres pooling and things like that, and replication and things like that. PG Bouncer is a tool, and we do have people that run those tools between Azure and Postgres, and it works fine. So.
Okay, thank you.
I have one question that sort of relates to the interface between GraphQL and SQL, which are not always quite the same, especially when you look at sort of design practices and how you should be quote unquote designing your schema. So what I'm wondering is, is there, as far as I understand, what Azure currently does is sort of directly map the Postgres schema into GraphQL, right, to the extent that is possible. But do you foresee that it might be possible to sort of add an additional layer to that translation and just translate SQL semantics into nicer GraphQL schemas? I'm thinking specifically of like connection objects, which, as far as I can tell, are like sort of the gold standard for how people do GraphQL inside and out. But also, if you had to insert these manually into your schema, you would end up with 300,000 tables, for instance.
Yes. Yeah. So I have, I guess, a few different answers to that question. So one of them is in the case of like connection objects specifically. So relay is, I don't know if you're familiar with it, but it's a particular like spec on top of a spec on top of GraphQL that sort of specifies how to do connection objects, things like that. And that's something that we want to bake some kind of support directly into GraphQL engine, but that's not super satisfying because then you have to modify the code every time you want to do something like that. So there's a few different approaches that we've looked into, and some of which we support, some of which we don't support yet, but we want to support for trying to decouple those things. So one of them is the simplest thing is that you can write a SQL view. If you can write a SQL view, then you can expose that through the API, and that can do whatever you want. And then we also allow you to sort of query functions, SQL functions as well. But that's not always sufficient because sometimes you want to do something that's fancier than that. And so we have a little bit of support right now. Like the sort of nuclear option that you can do is you can run your own GraphQL server that sort of generates, maybe if you want like some particular object that's not structured in the same way that is in your SQL, you can run like a separate server that serves that one thing, and then you can hook that into your into the sort of stitched together GraphQL schema. And currently we don't we support doing that at sort of the top level of a query, but we're also having support for being able to do joins across those things, and so that's I think that's something that will significantly help what a few people are doing. But even that is sort of not quite, I think, what we would like to have in sort of long-term ideally. So there's sort of another thing that we're working on, which is giving you sort of the ability to insert code somewhere into the process between like loading the information from the database and how it gets into the GraphQL schema. And that's something that I don't know as much about what the status of that is. It's something that we are working on. I'm just not directly involved in that particular feature, but it is it's something that we would like to support and that we intend to support, but we don't have that right now.
Cool, thank you.
What about subscription and stream-oriented, real-time stream type stuff? What's the status? I'm not familiar actually with this, the whole setup here.
Yeah, so there's certain extensions of the GraphQL spec that's very common for supporting subscriptions, which usually are used to send deltas over the, so like send events basically to say, oh, this thing was created, this thing was dropped. We actually currently don't support that, but we do support the less common thing, which is sort of library type subscriptions where you can sort of send an ordinary GraphQL query and we'll just send you, we'll like push an event to you every time the output of that query changes. And our implementation right now of that is actually not particularly clever. We do a lot of work to basically, if you have a lot of different people listening on the same kind of query, we'll like only execute that query once for all those people. So we do a lot of work to reduce the load if you have a lot of different users, but we don't do a lot of work to avoid refreshing the data. A lot of that just ends up being, in a lot of cases, we run the database. There is definitely some interest in supporting sort of more like a trigger-oriented workflow where when somebody modifies some table that's used by the query, then we'll send not the whole query back, but just say, this is what changed. That is certainly, it's not easy to do for various reasons because of the fact that like it can be challenging to know exactly what a query actually touches and when different queries need to be updated. But it is something that we've considered. It's not something we're working on at the moment, but it is possible. But that said, like a lot of people do use the library feature that we have right now at scale, and it does work pretty well for their needs. I think because of the fact that most of the time when people are doing things like this, they have like a query that's parameterized And it's okay if the variables are different, like we can still batch those two things together and we only run one query. And then a bunch of different users and different machines are subscribed to that query, and so there's sort of one thread that's pulling the database. But for the most part, they're all kind of listening to that same thread, and that works okay.
Okay, thank you.
I've got a question from a different angle. First of all, I really like the ability that you can stitch together services. I mean, that sort of makes the system compositional. You can have two teams build some service, and then you see, oh wow, we can build a service from this service. So that works great. The other typical difficult problem in these systems when they evolve is upgrading, so changing data schemas and nevertheless serving the same data to the old clients which don't get updated. Well, do you have some structured thinking? I mean, have you thought about that problem? What is your current answer there? Is the user on its own, or is there some recommended path from Hasura?
Yes, that's a very good question. So there is some support, like in the GraphQL specification itself, for deprecating things, but that's like kind of the extent that the GraphQL specification says about versioning. We actually currently don't support marking things as deprecated either. That's something that we're actually planning to add very, very shortly. The more general question of versioning these APIs is something we've thought about. I don't think we have like a concrete solution to it. It's challenging because some of it just comes down to like thinking really hard about your API design. I think for a lot of the users that we have, they are not super worried about it because they're not like our target audience is not people that are using this to sort of expose an API to third parties, but just sort of to expose an API to themselves. But sometimes they do still have to worry about that sort of thing. And I think that there's various things that we've considered about versioning, like, oh, we could expose multiple views into this sort of same schema, and then we could have different ways to specify, like, here's a compatibility view, and when you specify a version in the query parameter, then we'll give you like, a different view into the same schema. But none of these things are particularly clever. I think that that's something that when it comes time, if and when it comes time to implement that, we'll have to think a lot harder about how we want to do that.
Thank you.
More questions? Otherwise, Alexis, please stay, because maybe in the end there will be more questions for you.
Thank you all for your questions, all good questions.
Thank you for presenting.
Du kannst auf deine Slideshow wechseln und du wärst bereit.
Ja, aber
du bist noch im Fullscreen-Modus dort. Escape.
F10.
Genau, ja.
Stopp. Nein.
Window, Tab.
Minimal. Nein.
Aber ich glaube, du kannst den Tab wechseln, oder? Eins links.
Control Command F.
Aber ich muss das kurz abschalten.
Alex, ja.
Okay.
Here we go.
Share again. Okay, so this will be very quick. I will just introduce quickly what resources we have, because as Alexis said, we want to make it easier for the open source community to be able to contribute. to the server code, we have currently quite some contributions for the CLI because Go is very popular, and also for the console, but most of the contributions we have for documentation and for community content, for example, sample apps or deployment guides for Google Cloud or whatever. So we want to, because there are a lot of Haskell developers, and then we asked ourselves, why don't we have more contributions? And then we actually had to go back and make sure that it's actually easier to contribute because the code is quite complex. So we published this server code architecture that explains about the architecture of the servers. I mean Alexis has introduced this before. Then we have on the server a contributing guide that shows you how you can set up the development environment. And if you try any of this or read through anything and something is not working, please reach out to one of us so that we can update this. And now we have some issues that are either, if you're starting, good first issues for the server, and help wanted. These are, I think, a little bit more advanced ones. But if you want to get started, you can go for just filter for good first issue. And Alexis and I are currently working on, we're keeping an eye on the server issues to make sure that we actually can identify those that are easy or at least possible to contribute. Alexis, do you have anything to add to this?
Not a ton to add, I guess, but I think I will just say that it's definitely, I think we're very aware of the fact that a lot of the current code is kind of difficult if you're not, if you're just kind of coming into it for the first time. We don't have a lot of guidance. A lot of the time when I started working here, a lot of how I figured out how to get started working on things was to ask other people, which is not great if you want to have people that can contribute. So I think from our point of view, if people are interested in contributing, we're both, one, very happy to help people out and sort of point them in the right direction and answer questions that they have. We have a Discord server. If you use Discord, we can also just kind of have conversations on GitHub or something like that. And in addition to that, those kinds of questions are really helpful for us to figure out what the holes in our documentation are, because obviously after you've been working on something for a while, it becomes easy to forget what was hard when you started working on it. So that is something that we would appreciate a lot for anyone who's willing to be the guinea pig and try those things out for the first time.
Yes, and also if you find an issue that looks interesting, but you're not sure about something, you can just comment on the issue and then someone from the server team will help you get started. So we went through this. So also we are hiring Haskell engineers, and I'm currently the only person working from Switzerland, so it would be cool to have a colleague here. So if you're interested, just go on the server website and check out what jobs we have. Yes, otherwise, thank you. Alexis, if you share your slides later, then I can share it with the people here, and then they have both our contact details and everything as well, if this is
Sure.
okay.
I will definitely send them to you.
Cool. Otherwise, thank you very much for having me here, and have a nice evening, and thank you, Alexis, for presenting.
Yes, thank you. Thank you very much.
Thank you guys, girls, for coming. It's good. Did you reserve the ale house again?
I did, yes.
So yeah, if you'd like to join us afterwards, Alexis would have loved to have you here.
Alexis, come over here.
Yeah, come on over.
You know me a beer.
Well, next time one of us is in Chicago.
Hey, she will come in June for the Haskell hackathon at Rapperswil. So she will
That's
be
right. I'll be.
Very
she
good.
will be a keynote speaker.
Awesome.
Yeah. And have you guys thought about doing as a project to hack on Hasula? Because we are always very happy to receive we have a project page so everybody can submit one. So if you want to submit hacking on Hasula for that, I'm pretty sure people would be very interested in it.
I think we should do that, Alexis. Did you hear?
Yes, definitely. Yeah,
Okay.
yeah, absolutely.
Yeah. Okay, perfect. I have stickers here if you want, and otherwise see you later at the booth. Bye, Alexis.
Bye, Alexis.
Say goodbye.
Bye.